Welcome back, we're nearly at the end of the course now. This is C10 Chemical Analysis, and the first thing really to be talking about is what is a pure versus impure substance. Well, a pure substance is one that is made up of just one substance. That substance can either be an element or a compound, for example, distilled water. Now you need to know that distilled water's melting point is at 0 degrees C and its boiling point is exactly 100 degrees C. But in everyday language we use the word pure to describe something that has had nothing added to it, for example, pure milk, pure orange juice. So an impure substance is something that contains a mixture of elements and compounds, so for example, tap water and alloys. A formulation then is a type of impure substance. It is a mixture of elements and compounds, but a formulation is specifically designed as a useful product for a particular purpose, and examples include makeup, medicines and paints. They contain precise quantities of specific ingredients. How do we test for purity then? Well, a pure substance will have fixed melting and boiling points. They will melt or boil at a single temperature rather than over a range of different temperatures. So the method is to take a small amount of the sample, heat it using a Bunsen burner to its known melting point. Now, pure substance will instantly melt at that point, and impure substance will melt before that melting point and over a range of different temperatures. So we can measure the temperature at intervals and plot a graph using temperature versus time on the X and Y axis. Now we use a small amount of the sample because large amounts of the sample take longer and that can affect our results. So our temperature versus time graphs for a pure substance and impure substance will look like these. So our pure substance is like our typical staircase graph, and those 2 points there are the melting and boiling point. And just a quick note here as well, that if we increase the difference between the melting point and the known pure melting point of a substance, the lower that substance's purity. And the next topic is chromatography. Now, chromatography separates mixtures so we can identify the different parts. And there's essentially 6 steps to how this takes place. So number 1, we draw a pencil start line on our piece of paper. We then mark known and unknown spots of dyes and inks onto the start line. We then hang the paper in a beaker of water. We need to ensure that that water is below the start line and attach a lid. We then allow the sample to run up the piece of paper. Step 5 is to remove the paper when the sample reaches the top and mark the solvent front. And then finally, we're going to analyse that chromatogram. Now, sometimes the exam board like to ask you about mistakes that have taken place in the experiment. So the first one they might ask you about is if the water is above the start line. Now, if that is the case, the inks will just dissolve into the water. The next one is that if we draw our start line in pen, then it will run with the dyes. And the last one is that if we use the wrong solvent, then our samples won't run at all. Why do we need chromatography? Well, chromatography is used in forensic science as well as to identify banned substances in food and drinks. And we also need to apply the concept all the way back from C1, which is the spots lowest down the paper are going to be the least soluble. And this is because it's taking the most time for them to run up that paper. Now, there are 2 key concepts introduced here, and that is the mobile and stationary phase. The stationary phase literally is the paper involved in the experiment, and the mobile phase literally is the solvent. So the mobile phase moves through the stationary phase, carrying the components with it, and it's relative distribution between these phases that causes the separation of the spots. Now, if we have greater forces of attraction towards the stationary phase, the substance will move up the paper not as far in a given time. However, if we have greater forces of attraction to the mobile phase, the substance will move up the paper a greater distance in a given time. 2 quick notes here. A pure substance will produce a single spot in all solvents, and our samples must be able to dissolve in a solvent. If they are not dissolving in water, we would use ethanol. And then we have the concept of an RF value, which literally stands for retention factor. It is essentially a ratio. Now, the temperature and solvent used in the experiment must be kept constant to the database, but the time that we run the chromatogram for does not matter. So our RF value calculation is that RF equals distance moved by substance divided by distance moved by solvent. To calculate our distance moved by solvent, we need to take our ruler and measure the distance between the start line and the solvent front. To calculate the distance moved by the substance, we need to take our ruler and measure the distance from the start line to the middle of each spot. RF values are never greater than 1, and different substances have different RF values in different solvents. If we have an unidentified spot, we can identify it by using two ways. We could either compare the distances moved to our known data, those that move up the same distance are the same substance, or we can calculate its RF value and compare that to known data. And our final mini topic in this video today is gas tests. And so we're going to start with hydrogen. Usually we use the reaction between an acid and a metal, so for example zinc and hydrochloric acid. If they do ask you about this, how to obtain a test tube or boiling tube of hydrogen, what you can do is invert a boiling tube in a tray of water and the gas will displace the water. Once you've got your boiling tube of hydrogen, you can just ignite the gas. You place a lit splint into a boiling tube of hydrogen gas. A squeaky pop will be released if hydrogen is present and it will burn rapidly. To test for oxygen, you blow a lit splint out until it is glowing. You place it in a test tube full of gas, and if oxygen is present, it will relight. To test for carbon dioxide, you bubble the gas through the lime water, and if carbon dioxide is present, the lime water will turn cloudy. And finally, to test for chlorine, you place damp blue litmus paper in the gas. If chlorine is present, it will bleach white. So remember that chlorine is toxic. It can be obtained by the electrolysis of sodium chloride, brine. And why is chlorine useful? Well, it kills bacteria. And that's all for this video. So well done if you made it to the end, and see you next time.